Okay, hello guys. We're going to discuss trigonometry. Okay, so we're going to start trig. So we'll be focusing on reduction formula. So we'll be focusing on reduction formulas. Okay, so for you to understand the reduction formula, we need to understand the Cartesian plane. So I'm going to draw this our Cartesian plane. So this is our Cartesian plane. Let me take a different marker. So we have our 0 degrees, we have our 90 degrees, we have 180 degrees, and then we have 270 degrees, and then we have 360 degrees to complete a full circle. Okay, so now what we have is we're going to discuss the ratios, the trig ratios. And you know that our trig ratios, we have sine, then we have cos, and then we have what? We have tan. So in grade 11, we'll be discussing these three ratios. Okay, so now what we have is that in the first quadrant, we're going to use what we call the cast rule. We're going to use what we call the cast rule. You just write cast. So basically the cast rule, it tells us that in the first quadrant, only sign is positive. No, in the first quadrant, in the first quadrant, A means all are positive. It means in the first quadrant, all ratios are positive. And then in the second quadrant, only sign is positive. It means cos and tan are negative. And then in the third quadrant, only tan is positive. And then in the fourth quadrant, only cos is is positive. Okay, so now when we take an acute angle, when we take theta to be any acute angle, so basically acute angles give the angles that are between 0 and 90 degrees. Those angles, we call them what? We call them acute angle. So if I take my theta to be an acute angle, it means it's in the first quadrant. It's between 0 and 90 degrees. So every time when you see theta, just know that this theta is going to be an acute angle. It's between 0 and 90 degrees. Okay, so it means in the first quadrant, when I'm looking at the first quadrant, now when I'm looking in the first quadrant, it means my sine theta, you can see that my sine theta here is positive. Then what do we have also? It means we have also cos theta, which is positive also. And we also have the tan theta, which is also what? Which is also positive. So this is what we have from the first quadrant. We have that sine is positive, cos is positive, and tan, it's also positive. Okay, then another thing that we have in the first quadrant, since if I can say 90 degrees minus theta, it means I'm saying 90 degrees minus an acute angle, which it'll lend this the first quadrant. So when I say 90 degrees minus theta, it will lend this the first quadrant. So it means, so now what do we say? When I have sine of 90 minus theta, so basically when we are dealing with sine, when we want to reduce from sine, when we are using 90 degrees minus theta, so what we do is we say this sine and cos, they are co-ratios. So sine here change even cos. So when we reduce, you have cos of theta. Whenever we dealing on 90 and 270, it's on the change from sine to cos. Only here reduces sine and cos 90 degrees or 270 gonna modi change. So it means now if I have cos of 90 minus theta, then we check our cos. Where is this thing? 90 minus theta is in the first quadrant. Then cos cos is positive. You change from cos to what? To sine theta. Okay, so you already discussed about the co-ratios, the sine and cos. So when we see cos sine and cos, so they change. Remember, that's why if you can check this thing from your calculator, if you can check and use your calculator, you will see that let's say for example I say sine of 30. What is sine of 30? Sine of 30 gives us, when you punch on the calculator, gives us 1/2. Then if I reduce this thing, I can say sine 30 is basically equals to against 90 minus an acute angle. Horem 30 could to how much? Could 60. Then we said when we see 90 degrees, sine it changes to what? To cos. Cos of an acute angle, which is 60. You can see that, ne? So when you punch on a calculator, you'll see that the cos of 60 is equals to 1/2. Now sine 30 is equals to, it means sine 30 is equals to the cos of 60. You can see from that, ne? So this is from when we are dealing with things from the first quadrant. So it's either we have sine theta, cos theta, tan theta, all positive. Sine 90 minus theta is cos theta, cos 90. So this ones, they are co-ratios. They are co-ratios. As long as they add up to, when you add those angles, they add up to 90 degrees, right? Or high, we can change from sine to cos, from cos to sine. When we see 90, yeah. Then now let us go to the second quadrant. Second quadrant is when I take this 90 degrees, then I plus it with theta. If I take 90 degrees, then I get plus any acute angle. So it in Kisagamo the second quadrant. So now we have the second quadrant. We have the second quadrant. So in the second quadrant, what we're going to have, if I say sine of 90 plus theta. So if I have sine of 90 plus theta, 90 plus theta is in the second quadrant. We'll check our sine, how is it positive or negative? Sine is positive. So it means how 90 I change how about cos of what? Cos of theta. So sine is positive. We'll check up sine here, this ratio. Sine is positive, and then 90 degrees. You change it to what? Cos theta. Then if can cos of 90 plus theta. Firstly, we'll check a cos. Cos here, how is it in the second quadrant? Cos, is it positive or negative? Cos is what? It's negative. We were negative. Then we want 90 degrees here. You change it to what? To sine. Sine cos of 90 plus theta is equals to what? Minus sine theta. So it change only if there's plus or minus 90 degrees. That's when we change our what? That's when we change our ratios. Now, okay, and then so if I'm given, for example, if you are given tan theta, so if you are given tan of 90 plus theta, our more now we will auto crowd below osinyanako. You are just going to say is equals to sine of 90 plus theta over cos of 90 plus theta. Identities. Tan is basically sine over cos. Then you change this one, you change this one according to this. Ne? Okay, that's why but tan change. So we'll discuss this thing. Just know how tan how change is basically sine over cos. But here you'll understand it better how when you're going to deal with identities. Okay, now we go to sine. So we have 90 plus theta, 90 plus theta, or we can have 180. If I say 180 minus theta. So now if I have the sine of 180 minus theta. So basically the sine of 180 minus theta, check, it's in the second quadrant. Sine is what? Is positive. Sine theta. It's 180. It change only sine to cos if there's 90 degrees. Okay, then now we have cos of 180 minus theta. So now I check up 180 minus theta is in the second quadrant. It means cos is what? Is negative. Minus cos of theta. Then what do we have again? Then we have tan of 180 minus theta. Then we'll check our tan in the second quadrant, or it's only sign is positive. Minus what? Minus tan of theta. This is how we reduce basically. Yeah? Okay, so I will discuss the or what happens in the third quadrant and in the fourth quadrant. Then we'll on the next video. Thank you.